For this lesson, we're going to take a look at scale factors and perimeter. In earlier math courses, we started the concept of similar objects. Objects would have the same shape but not the same size. One way of describing the enlargement or reduction of an object proportionately is by scale factors. I see that the rectangles B, C, and D are all just scale factors of A, which means that they all proportionally have the same size. So I can say that if I'm measuring them, and I'm not going to expect you to measure them, I'm just going to state what they are, that the length of rectangle B is going to be 6, and the length of rectangle A is going to be 3. There's 3, there's 6. At the same rate, the length of rectangle C is going to be 4.5, and the length of rectangle D is going to be 1.5. If I measure out the widths, the width of A is 2, the width of B is 3. Oh, sorry, the width of B is 4, not 3. The width of C is 3, and the width of D is 1. So now I can use this for all of my ratios. I'm going to say that the length of B is 6, length of A is 3. When I divide them, then I get 2. The length of C is 4.5. This is still 3, which would give me a ratio of 3 over 2, or 1.5. This is 1.5 and 3, which is the same as 1 over 2, or 0.5. If I'm doing the widths, well, the width of B is 4, the width of A is 2, the width of C is 3, and A is still 2, and the width of D is 1, and A is still 2. This would be the same as 2 over 1 or 2, 3 over 2 is 1.5, and 1 over 2 is 0.5. I can state that the length of B is 2 times the length of A. The width is 2 times the length of A. The length of C is 1.5, and the width is 1.5 of what A is. And for D, it's going to be 0.5 of A and 0.5. So, a linear scale factor describes the enlargement or reduction of a length. It is described as a ratio in the form of A to B, or as a rational number where the number on the left-hand side is the numerator and the number on the right-hand side is the denominator. We can also do it as a percentage. So, the linear scale factor of B from A is 2 to 1, or 2, which would be 200% when I times it by 100. For C, it's going to be 3 to 2, or 1.5, which would be 150% of what A is. And D is going to be 1 over 2, or 0.5. D is 50% of what A is. A scale factor greater than 1 describes an enlargement. We're making it bigger. If it's between 0 and 1, it's a reduction. We're making it smaller. If I do the same process for the circle, then I'm going to find the radius of all these. Well, my first radius is going to be 2 centimeters. The radius of B is going to be 4 centimeters. The radius of C is going to be 3 centimeters. And the radius of D is going to be 1 centimeter. Circles B, C, and D are enlargements or reductions of circle A. Determine the linear scale factor in each case. Well, for B, it would be 4 over 2 or 2. For C, it would be 3 over 2 or 1.5. And for D, it's going to be 1 over 2 or 0.5. The perimeter of a circle is called the circumference, which can be calculated using circumference is equal to 2 pi r. So for A, the circumference is going to be 2 times pi times the radius of 2, or 4 pi. For B, that would be 2 times pi times 4, which would be 8 pi. C would be 2 times pi times 3, which would be 6 pi. And D would be 2 times pi times 1, which is just 2 pi. If I'm looking at the ratio of the circumferences, well, 8 pi over 4 pi, the pi's will cancel out, and I'm going to get 2 over 1, or 2. For C over A, it's going to be 6 pi over 4 pi, which would be the same as the pi's will cancel out, and 6 over 4 is the same as 3 over 2, or 1.5. And I'm sure you can guess where this is going. For the last one, it's going to be 2 pi over 4 pi, which is the same as 1 over 2, or 0.5. What do you notice about the linear scale factors in part B and the perimeter scale factors in part A? They're the same. Scale factors. All right. If I'm looking at the relationship between a linear scale factor and its perimeter, the first one has been done. So if I have the dimensions of a rectangle are 3 by 5, then the perimeter would be 2 times 3 plus 2 times 5, 2 lengths, 2 widths, which is going to give me 16. The linear scale factor that I'm applying to it is going to be 2 to 1, which means that I'm going to double the original dimensions, which is going to give me 6 and 10. The new perimeter would be 2 times 6 plus 2 times 10. And that's going to give me 32. When I divide the perimeters, I had a linear scale factor of 2, and my perimeter scale factor was also 2. This should be pretty telling right from the get-go. Let's try the second one. If I had 2 times 2 plus 2 times 6, then it's going to give me 16 centimeters. When I triple each of these dimensions, or have a scale factor of 3, I'm going to multiply both dimensions by 3, and I get 6 by 18. If I have 2 times 6 plus 2 times 18, then my perimeter is going to be 48 centimeters, which means that I'm going to take my new perimeter, 48, divide by my original perimeter, 16. That would give me 3 over 1, or 3. And once again, I can see that they match. Going on to the third one, in this case, I have a perimeter of 30, and now I'm going to do a reduction. I'm going to have a scale factor of 1 to 3, or 1/3, which means I'm multiplying 9 by 1/3, or dividing 9 by 3, and I get 3. 6 times 1/3 is going to be 2, so I've actually made it smaller in this case, and my perimeter is going to be 10. Well, 10 divided by 30 is the same as 1 over 3. which, once again, matches my scale factor. For the last one, this is going to be 30 centimeters, and I'm going to have a scale factor of 2 over 3. So 3 times 2 is going to be 6, divided by 3 is going to be 2. So 3 times 2 over 3 is going to be 2. 12 times 2 over 3 is going to give me 8. And now I'm going to wind up with 20 centimeters as my perimeter. 20 divided by 30 is the same as 2 over 3. And once again, I have the same factor. So I can state that the perimeter scale factor is equal to the linear scale factor. If I'm completing the table using the linear scale factors in part A, then I'm going to say, well, that P had a scale factor of 2. So this is going to be an enlargement. Q had a scale factor of 3. That is an enlargement. R had a scale factor of 1/3. It's between 0 and 1, so that is a reduction. And S had 2/3. That is also a reduction. For example 1, if I'm determining the scale factor that will transform diagram P to diagram Q as a ratio, a rational number, and a percent, well, I can just take a look at one of the dimensions and say that this was 4 originally, now it's gone to 3. What I'm going to do is I'm going to put my new one for Q on the left and my original one for P on the right. Or I put my new one in the numerator and my original one in the denominator. If I want to do it as a percentage, I would actually do 100 multiplied by that ratio, which is going to give me 75%. For example 2, Sarah increased the length and width of a rectangular 8-inch by 10-inch photograph by a factor of 5 over 2. Is this an enlargement or a reduction? Well, when I'm given the scale factor, if the number on the left is bigger than the number on the right, it is an enlargement. Calculate the new dimensions of the picture. Well, if it's got a scale factor of 5 over 2, then I would say that it's going to be 8 times 5 over 2 by 10 times 5 over 2. This is going to give me 20 inches by 25 inches. If I want to show that the ratio is going to match in terms of the new perimeter and the old perimeter, then I would say that 2 times 20 plus 2 times 25, the new perimeter, divided by 2 times 8 plus 2 times 10, the old perimeter, is going to give me 40 plus 50 over 16 plus 20. That's going to give me 90 over 36. I can divide both these by 18 on the top and the bottom. which gives me 5 over 2.